Welcome to the deep dive. We're here to cut through the noise, get you properly informed on the big topics changing our world. And today, well, we're diving deep into something that's, let's say, quietly and maybe sometimes not so quietly reshaping a huge industry, artificial intelligence in the automotive world. Now, when you hear AI in cars, your mind probably jumps straight to, self-driving vehicles, sleek robo-taxis maybe. But our mission today, it's to go way beyond that picture. We want to uncover how AI is impacting everything, the whole automotive value chain, from designing cars, building them, to your experience inside the car, maintenance, business models, even, yeah, the big societal shifts. Expect some surprises, maybe a few aha moments. We're aiming for that shortcut to being genuinely well-informed. We'll tackle some big questions, too. Like, how do these cars actually see? Who's responsible if something goes wrong? What does it mean for jobs, for cities? So let's unpack this. When we talk AI in cars, it's really this foundational set of computer techniques changing, well, pretty much everything.
That's exactly right. It's fascinating because AI here isn't just one thing. It's a whole collection of advanced techniques. We're talking machine learning, deep learning, computer vision, natural language processing. They all work together. They let vehicles and the whole ecosystem around them learn and reason and make decisions almost like humans do.
And it goes beyond just the driving part, right?
Yeah.
You mentioned manufacturing.
Oh, absolutely. Think about how cars are actually made. AI powers robots for incredible precision on assembly lines. It analyzes factory data to predict when equipment might fail before it breaks down.
Minimizing downtime.
Exactly. Saves a lot of money. And it even helps manage the supply chain, forecasting demand by looking at social media, weather, market trends, much smarter production.
Okay, so that's the factory. What about inside the car itself?
Well, AI is totally changing the experience there too. Personalized infotainment systems, learning your music tastes, climate settings. Some systems use facial recognition to adjust your seat, mirrors, even monitor if you're getting tired or distracted. That's a big safety feature.
Right, and voice commands are way better now, too.
Much better, thanks to natural language processing. You can talk to the car more naturally, control systems, even order stuff while you're driving. It's like a co-pilot.
And maintenance. You said AI helps there, too.
Yeah, through predictive maintenance. Sensors all over the car feed data back to AI algorithms. These algorithms spot patterns, predict potential issues like a part wearing out before it becomes a major failure.
So you get it fixed before you break down.
Precisely. Reduces breakdowns, lowers repair costs, and actually makes the car last longer. It's like having an onboard mechanic constantly checking things.
What's striking is how all this data connects. You mentioned AI native companies. It sounds like this virtuous cycle.
It really is. Think about it.
Yeah.
Real-world data on, say, which parts fail often gets fed straight back to the engineers.
So they can improve the next design.
Exactly. Or data on how people use the infotainment helps design better interfaces. It's continuous improvement.
So autonomous driving, the self-driving part, it's like the most visible tip of this huge AI iceberg.
That's a great way to put it. It's definitely the most visible, the most complex, but it's not the only goal. Maybe not even the most revolutionary part behind the scenes.
Okay, so we've seen AI is everywhere, from the factory floor to predicting breakdowns. But yeah, let's get to the headline act. Self-driving. To really get our heads around that, we need some common ground, a shared language, and that's where I believe the SAE levels come in.
Absolutely crucial. SAE J3016 done. It's the global standard, basically. Sets out 6 levels of driving automation, from level 0 nothing up to level 5 full automation. It's designed to stop confusion, give everyone, engineers, regulators, you, a clear way to talk about what a car can actually do, and importantly, what the human needs to do.
Okay, standard levels. Got it. Are
Yeah.
there key terms we need to know within that standard?
Yes, 3 main ones pop up a lot. First, the dynamic driving task DDT. That's basically everything involved in the real-time act of driving. Steering, braking, accelerating, plus watching the road, responding to things. Not the strategic stuff like choosing your destination, just the driving itself.
Okay, DDT. What else?
Second, the operational design domain, ODD. This is critical. It defines the specific conditions where an automated system is designed to work safely. Think specific road types, maybe only in a certain city area, below a certain speed, or only in good weather. It sets the system's limits.
Right, so it can't just drive anywhere, anytime, unless it's designed for that specific domain.
Exactly.
Huh.
And third is fallback. What happens if the system fails or the car goes outside its ODD? The fallback is the planned system or driver to bring the car to a safe state, a minimal risk condition, the safety net.
DDT, ODD, fallback. Got it. So let's walk through these levels, 0 to 5.
Okay. Level 0, no automation, simple. The human does everything. all the DDT all the time. The car might beep warnings or brake in an emergency, but it doesn't drive itself.
Standard car, basically.
Pretty much. Then level 1, driver assistance. Here, the system helps with either steering or speed control, but not both at once. Think adaptive cruise control or lane keeping assist. Human is still fully in charge, supervising constantly.
Okay, just a little help.
Right. Now, level 2, partial automation. This is where it gets interesting. The system handles both steering and speed control together, but only within its specific ODD. But crucially, the human must monitor the environment, they call it OVDR, object and event detection and response, and be ready to take over instantly. It's hands-off, maybe, but it's absolutely eyes-on.
Eyes on. That's the key bit people sometimes forget with systems like autopilot or Super Cruise.
Exactly. You are still responsible. Now, level 3, conditional automation. This is the big jump, the great chasm.
Why the chasm?
Because here, within its ODD, the system does the entire DDT, including monitoring the environment. The human doesn't need to supervise. It's eyes off.
Ah, so you can actually look away.
Yes, but you have to be ready to take back control if the system asks. You're the fallback-ready user. Mercedes Drive Pilot is an example certified level 3, but only in highway traffic jams under 40 mph. Responsibility shifts from human to machine. That's huge.
Okay, massive shift. What's next? Level 4.
Level 4, high automation. The system does everything, the DDT, and its own fallback within its ODD. No human intervention expected within that domain. If it hits a problem or leaves the ODD, it handles bringing the car to a safe stop. You might not even need a steering wheel and a level 4 car designed for a specific purpose. Waymo's robotaxis in Phoenix, that's level 4.
Right, the driverless taxis. And the final goal.
Level 5, full automation, the dream. The system handles all driving under all conditions a human could. Unlimited ODD. No level 5 cars exist commercially today. Still a long way off.
That great chasm you mentioned, between level 2 where the driver's responsible and level 3 where the system is,
Yeah.
that sounds like a legal and technical nightmare.
It absolutely is. That handover, okay, human, you need to take over endodobia, is incredibly complex. How does the system know reliably? How fast can a distracted human safely re-engage?
The liability question must be enormous.
Huge. And that's exactly why some companies, particularly robotaxi developers like Waymo, are just skipping level 3 entirely. They're going straight for level 4.
To avoid that messy human handover.
Precisely. Take the human out of the critical driving loop altogether within the ODD. It simplifies the problem in a way, though achieving level 4 is incredibly hard itself.
So getting to these higher levels, the stepping stones are really the systems we see today, right? The Advanced Driver Assistance Systems, ADS.
That's exactly right. ADSS are the real-world level 1 and level 2 systems. They're not just nice-to-haves. They're critical safety tech, and they're teaching cars the basics, bit by bit.
Using sensors like cameras and radar.
Primarily, yes. Cameras, radar, sometimes ultrasonic sensors,
Yeah.
all feeding data into onboard computers running AI. Let's look at some examples. For controlling speed, adaptive cruise control, ACC, is common. It keeps a set distance from the car ahead, braking and accelerating automatically. Some handle stop-and-go traffic. It's constantly reacting.
More than just holding speed.
Much more. Then automatic emergency braking, AEB. Super important safety feature. Detects potential crashes, brakes automatically if you don't react. Modern ones see pedestrians and cyclists too.
Okay, that's forward motion. What about staying in lane?
For that, lane departure warning, LDW, just alerts you if you drift. Lane keeping assist, LKA, gives a gentle nudge back into the lane. And lane centering assist, LCA, actively keeps the car centered. Combine ACC and LCA, and that's your level 2 system right there.
Yeah, that nudge. It definitely feels a bit weird the first few times. Like, the car has opinions. What about other things like parking or blind spots?
Absolutely. Blind spot monitoring, BSM, warns you about cars you can't see. Rear cross traffic alert, RCTA, helps when you're backing out of a spot. Parking assistance uses sensors, sometimes cameras for a 360 view, some even park the car for you. Plus, things like driver drowsiness monitoring, using a camera to watch your eyes for fatigue, traffic sign recognition showing speed limits on the dash, and automatic high beams. They all add up.
So these ADS features are becoming pretty standard, but thinking bigger picture, with millions of cars using these systems all the time, what's the strategic play here? Is it just about safety and convenience?
No, there's a massive strategic implication. The sensors used in ADS cameras, radar, are the same foundational sensors needed for levels 3, 4, and 5.
So every car with ADS is collecting data.
Constantly. Every mile driven generates invaluable real-world data, especially data on those weird, unpredictable edge cases, and, crucially, how the human driver reacted. You can't easily simulate